we can say least common multiple, and HCF, which stands for highest common factor. So I'm going to start with some basics in here, and in this video we are going to go through GCSE level 3 to level 5. So starting from some basic ones, and we move to slightly more advanced topics in this section. Looking at multiples of a number, as you can see from the word multiples of a number, it's the numbers that multiplication of that number to different numbers, including basically starting from 1, 2, 3, 4, and 5, and so on. So if we want to look at, for example, multiples of 9, 9 times 1 is 9, times 2 is 18, times 3 is 27, times 4 is 36, times 5 is 45, and times 6 is 59, and so on. So multiples of 9 are 9, 18, 27, 36, 45, 54, 63, and so on. And in the same way, when we look at multiples of 16, we have 16 times 2 is 32, times 3 is 48, times 4 is 64, times 5 is 80, times 6 is 96, and times 7 basically would be 112, and that would continue there. So when we look at multiples of a number, we can time it to 1, 2, 3, 4, 5, and so on, and write it down, and that basically represents the multiples of a number. When we look at the factors on the other side, we are defining factors of numbers, or numbers that are the number is divisible to. For example, just want to give you an example. If I have, for example, in here 45, 5 is a factor of 45 because 45 is divisible to 5. Or 9 is divisible, again, factor of 45 because 45 is divisible to 9, and so on. But how we can find the total factors of a number rather than trying to guess like this? We want to find out total factors of a number. A method that I've put in here is the example. I will show it in the example when we look at finding factors of 36. So we look at in here, and we start again from 1, 2, 3, 4, 5, 6, 7, and try to see what are the numbers that we can make with those numbers to multiple multiple and basically result in the 36 that we have. So starting from 1 times 36 is 36. Then we move to the 2. 2 times 18 is 36, which we still can write. Then going to the 3, and 3 times 12 is 36. So we still have, we can just go on. We try 4, and 4 times 9 is 36. And 5. 5, I haven't put anything in here because 5 times something giving 36 basically doesn't have answer. So I really don't need to consider this. So I move on after 5 to 6, and then I find that 6 times 6 also gives 36. As soon as I see a repeated number, in here 6 and 6 are repeating, I will stop, because the rest of that would be the same as before. So if I go on, the rest would be 7, we don't have anything timing, 7 gives 36, 8, there is nothing, and then after that would be basically 9 times 4. But 9 times 4, already we have 4 times 9, which is the same thing. So basically we can stop at 6 times 6 because we have a repeated number, and that is 6 and 6. Now that we did this, we will write down all of these numbers that they time to each other and they make 36. So this is starting from here, we have 1, 2, 3, 4, 6, 9, 12, 18, and 36. And we don't need to write and repeat the 6 twice. So all of these numbers in here, 36, is divisible to those numbers. And we have in total 9 numbers that 36 is divisible to, including 36 and 1. So we have this list is factors of 36. Now, going to the next page. I have put in here a quick questions for you to try. Write down the first 10 multiples of 11, and also write down factors of 48. This is a GCSE level 3, and in this point, if you want to, you can pause the video and make a try and give yourself about two minutes for these 2 questions. So if you have tried these, I'm going to quickly go through the answers. 10 first multiples of 11, 11 times 1, 11 times 2, 11 times 3, 11 times 4, 11 times 5, 11 times 6, and go so on. We just go in here, 99, and 11 times 10 would be 110. So this is the first 10 multiples of 11. When we look at factors of 48, again I start from 1. 1 times 48. 2 times 24 gives 48. 3 times 16 gives 48. 4 times 12 gives 48. 5 times no number gives 48, not whole number. And 6 times 8 gives 48. And 7 times nothing gives 48 as a whole number. And we have again 8 times 6. But as you can see, we have 6 times 8, and 8 times 6 is repeat. So at this point, we basically stop. So factors of 48 are, so the answer for that is 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Okay, so we carry on to the next level in here, which is definition of prime factors. If we look at factors of 3, for example, to find factors of 3, we start from 1. 1 times 3 gives 3. 2 times nothing gives 3. And 3 times 1 gives 3. But 3 times 1 is a repeat. We can just not consider that. So the factors of 3 are just 1 and 3. In the same way, if we have the 2, we have 1 times 2 gives 2, and 2 times 1 gives 2, but again, that's a repeat. The factors of 2 are 1 and 2. And if we continue with 19, we have 1 times 19, which is 19, and nothing else gives 19 until we get to 19 times 1, again, which is a repeat. Therefore, the factors of 19 are 1 over 19. These sort of numbers that they have just 2 factors, we call them prime factors. In a way, the prime factors, they are only divisible to themselves and to 1. Basically, any number is divisible to itself and to 1. So apart from that, they are not divisible to any other number. So they are only divisible to themselves and to 1. So if I start the prime factors to writing them down from here, you have 2, 3, 5, 7. I cannot put 9 because 9 is divisible to 3, so that is not a prime number. So we have 11, 13. I cannot write 15 because 15 again is divisible to 3. So 17, 19, and so on. So these are prime factors. So when we want to write the prime factors of a number, what we can do to find a prime factors? In here, we have 48, finding prime factors of 48. We can start doing this. We can write 48. 48 is 2 times, or we can start, say, 6 times 8. And 6 itself is 2 times 3. And 8 is 2 times 4. And 4, we will go basically until we have this, we cannot divide these two anymore to find out basically two numbers that they time apart from 1. So we have a 6, 2, I cannot go on further because that's a prime factor, and 3 is a prime factor in here. So I continue this 3 until I get, at the end of the 3, I just get these prime factors. So if somebody says what are the prime factors of 48, we can say the prime factors are 2 and 3, but we can also write 48 is equal to 2 times 2 times 2 times 2 times 3. So if I go to the next page, for this we have a different method that we can basically find out to use. What I just mentioned there, we can, as you can see in here, I have put it in this page, and this basically shows that finding sort of prime factors of 48, we have 48, we can write 48 is 6 times 8. And then we continue on the 3, for the 6, we can write 6 is 2 times 3, and 8 is 4 times 2. But 4 itself is 2 times 2. And as you can see, we go to a point that all of the last part in here are prime numbers. And therefore, we can write 48 equals 2 times 3. So I'm just going to show where this is coming. We are just going to time the end of the 3, 2 times 3 times 2 times 2 times 2. And if we write it into a power form, it would be 2 to the power of 4 times 3. Now, there is another method of finding this basic prime factors. And this basically, we can call it factor 3 or in a way, and we can basically this time try to do the same thing, but consider that we can start with just dividing to prime numbers, which are 2, 3, 5, 7, and 11, and in this order. So with 48, the first prime number we have is 2. Is it divisible to 2? Yes. So it is 2 times 24. 24, the first prime number is 2. Is it divisible to 2? Yes. So that would be 2 times 12. 12, again, the first prime number is 2, divisible to 2. Is it divisible? Yes. So that would be divided by 2. That would give us 6. And now when we come to the 6, is it divisible to 2? Again, yes. So that would be 2, and this would be 3. And the 3 itself is the prime number. So we have to stop in this point. And as you can now see in this example, what we have is 2 times 2 times 2 times 2 times 3. So we can write the same thing, 48 equals 2 times 2 times 2 times 2 times 3, which is 2 to the power of 4 times 3. So going to the next page, we have a quick, again, some practice questions. This is a level 4, and if you can pause the video in this point again to give yourself about 2 minutes for finding the prime factors of 56. and prime factors of 108. So if you have tried this, I'm going to look at basically the first one. I'm going to use the different methods, two different methods. I'm just going to start one with just the prime factor 3, and the second one with the prime factor 3. So just see how we will do both. So 56 is 7 times 8. 7 is a prime number, so therefore we cannot go further. On an 8, we can write 8 is 4 times 2. 2 is a prime number, but 4 can go again further. 4 is 2 times 2. So what we have is 7 times 2 times 2 times 2. We are looking at the end of the tree, so 56 is equal to 2 times 2 times 2 times 7, or 2 to the power of 3 times 7. Now, looking at prime factors of 108, this time I'm going to do the method on just start dividing to the prime numbers. So I'm just going to do the method that we are just dividing to the prime numbers. I'm going to use this section of the board. So I'm going to start with 108. Is it divisible to 2? 2 is our first prime number. Yes, so that would be 2. That would be 54. Is it divisible by 2? Yes, so that would be 2. That would be 27. Now 27, is it divisible by 2? No. So the next prime number is 3. Is it divisible by 3? Yes. So that would be 3. And that would be 9. So 9 again, starting from the first prime number, which is 2, it is not divisible to 2. The next prime number is 3. Is it divisible to 3? Yes. So that would be 3 divided 3 times 3. And we see the end numbers are now prime numbers. So we have to stop in this point. Therefore, these numbers in here, we can have 108 basically equals to 2 times 2 times 3 times 3 times 3, and that is 2 to the power of 2 times 3 to the power of 3. So now that we know how to find prime factors and multiples, we come to basically the next page, which is basically looking at the least or lowest common multiple, LCM, and then we will look at the applications of the least common multiple. So if we look at writing multiples of 9, we will have 9 times 2 is 18, times 3 is 27, times 4 is 36, times 5 is 45, times 6 is 54, and so on. 15 times 1 is 15, so that is still included on the factors. So 15 times 2 is 30, as 15 times 3 is 45, and 15 times 4 is 60, and again so on. So when we say least or lowest common multiple, these are the list of multiples of 9, and these are the multiples of 15. So what is the common multiple, a least common multiple? So if you can see in here, this 45 is a common multiple, and it is the least one because before that we don't have any other common multiple, and these numbers are going higher. So the least common multiple is 45. So the answer for here is 45. Now, what are the application of a least common multiple? The main application of the least common multiple is when we want to find a common denominator. So if I just give an example in here, for example, if I say 2 over 9 minus 1 over 15, if you remember, we did a common denominator in here when we did a timing or subtracting fractions. So the common denominator is the least common multiple. It could be a common multiple, but it is normally easier to do a least common multiple because we are dealing with a smaller numbers. So in here, the least common multiple is 45. And in a way, we are saying that 45 is divisible to 9 and divisible to 15. So 45 divided by 9 is 5. 5 times 2 is 10, so that would be 10. And we have a minus. 45 divided by 15 is 3. 3 times 1 is 3. So the answer in here is 7 over 45. Yes. So another way of looking at this is that we can always replace that 2 over 9 with timing both sides to 5, both denominator and numerator. So that would be 2 over 9 is equal to 2 times 5 is 10, 9 times 5 is 45. 1 over 15 is equal to timing both numerator and denominator to 3, so which is 3 over 45. So it's like saying that 10 over 45 minus 3 over 45, it is the same denominator, would be 10 minus 3, which is 7 over 45. So least common multiple, we can find a number that is divisible to both of the numbers that we are looking to find a common denominator. The other example in here is when we want to eliminate eliminating fractions in algebra. And still is the same thing, but even that is in the form of letters, the concepts are exactly the same. So if I look at, for example, a question saying that solve x divided by 3 minus basically x divided by 3 minus x minus 1 divided by 5 equals 1. So example is solve this. Still you can do the common denominator in here, and if you do the common denominator, basically this the common denominator between 3 and 5 is a least common multiple between 3 and 5. If we write the common multiples of 3 and 5, we will see 3 is 3, 6, 9, 12, 15, and 18. For 5, we have 5, 10, 15, 20, 25, and so on. So the least common multiple in here is 15. So if we are doing a common denominator, we can basically say in here that common denominator is 15, and 15 divided by 3 is 5. 5 times x would be 5x, minus 15 divided by 5 is 3. 3 times x minus 1 would be minus 3 times x minus 1. And that is equal to 1. And we continue solving this by timing both sides to 15, and then we will basically result, that would result into saying that 5x minus 3 times x minus 1 equals 15. But the point in here is that we could completely do the two stages in one go, and if I call this eliminating fractions, when we found the common denominator in here as 15, we can directly from here come and time everything from in the left and right hand side of this equation to 15. So x times 15, x over 3 times 15, basically, if I just time that to 15, 15 over 1, so 15 and 3 simplifies, so we will have just 5x minus x minus 1 over 5 times 15, so 15 over 5 would be 3, so we will have just a 3 times x minus 1 equals 1 times 15 is 15. So you can directly eliminate the fractions, or you can use a common denominator. And after that, you need to expand this and take the terms with x to the one side and the terms with the number to the other side, and you will continue solving for x. So as you can see, these are still simple applications. Still, there are a bit more advanced examples, but I will discuss that in the videos that relates to those topics. But as you can see, the lowest common multiple is important because of the major applications. So if you go to the next page, we are now looking at highest common factor. So highest common factor of 9, if you look at the factors of 9 are, I'm going to use the method 1 times 9, 2 times nothing gives 9, 3 times 3. And because that is a repeat, we stop in that point. So basically the factors of 9 are 1, 3, and 9. For 15, we have 1 times 15, 2 times nothing gives 15, but we have 3 times 5, and 4 again doesn't give any 15, but 5 times 3, which is again repeat, so we will avoid that. So the factors of 15 are 1, 3, 5, and 15. So in here, highest common factor is 3 and 3, highest common factor. So as you can see, even that we are saying highest common factor of two numbers, highest common factor of two numbers is always lower or equal to those one of those numbers, but always lower or equal. On the other hand, the lowest common multiples are always higher than those two numbers or equal again. So it is, you need to consider that when we say highest, doesn't mean that it has to be higher than those two numbers. Definitely it is lower or equal. So look at this, consider this, and then we come in here to applications of highest common factor. And the main application is when we want to simplify fractions. So if I want to say simplify a case of 9 divided by 15, 9 divided by 15, I can basically divide this by 3, divide this by 3, and that would be 3 over 5. And as you can see, this is the simplest form that we can do this simplification of 9 over 15. It is simplest form because we have divided to the highest common factor, which is highest common factor between 9 and 15 is 3. So we have divided to the highest number that we could divide both of those two numbers. And that is basically definition of highest common factor. When we look at simplification, this can go into more algebraic forms, and still the same things apply. So if we look at, for example, simplifying, for example, 14 x squared y divided by 21 xy. If you want to simplify this, this is algebra, but we need to simplify the number and look at the x's together and look at the y's together. So 14 over 21, still the same concept applies. So highest common multiple of 14 and 21 is 7. Dividing both of them to 7, that would give us 2 over 3. X squared over x is just x. And y over y is 1, so I don't need to write anything for that. So basically this could be equal to 2 over 3 of x. Now we go to the next page in here. This is now basically a different method to finding the highest common factor and lowest common multiples of two numbers. And I will be basically putting this into a basically form, in an example, explain this into an example. And this is about combining our skills from this lesson. So to find highest common factor or lowest common multiple of two numbers, we start with writing using the factor tree and write a number into its prime factors. So 96 divided by 2 is 48, divided by 2 is 24, divided by 2 is 12, divided by 2 is 6, divided by 2 is 3. So basically 96 is 2 times 2 times 2 times 2 times 2 times 3. So I'm just going to write it in here, 2 times 2 times 2 times 2 times 2 times 3. And when we look at 72, divided by 2 is 36, by 2 is 18, divided by 2 is 9. We cannot divide by 2, but the next number, prime number, is 3, so divided by 3 is 3. So 72 is 2 times 2 times 2 times 3 times 3. Now, if you look at the shape that I have in here, I have two ellipses that they have a common area. So I have, if you like, an ellipse that contains this section, and another one that contains this section. Between these two prime factors of these two numbers, first of all, I come and see what are the common prime factors. So we have 5 2's in here and 1 3 in this side, and in this side we have 3 2's and 1 3. The common element between these two is we have 3 2's and 1 3. It is 3 2's and 1 3. So this section is same as that section. So that is the common part of prime factors. So the common part, I'm going to put it in here, 2 and 2 and 2 and 3. Now, then for 96, which is on the left hand side, what is remaining is another 2 and another 2. For 72, which is on the right hand side, what is remaining is just a 3. So when we talk about common lowest common multiple, okay, let's start with highest common factor. When we talk about highest common factor, we are basically talking about this section that is common in between. So this section represents highest common factor, and that is equal to 2 times 2 times 2 times 3, which basically is 8 times 3, which is 24. So we need to time the numbers that are in the shared area for highest common factor. Now, when we look at the lowest common multiple is everything. So anything that you see in here, the whole thing we need to consider as a timing to find out the lowest common multiple. So in here, lowest common multiple would be equal to 2 times 2, which is coming from the left hand side, including the share area, so which is 2 times, again, 2 times 2 times 3. And then there's a 3 on the right hand side, which is again another 3. So if we time these together, we have 2 to the power of 5, which is 32. And then we have 9. 9 times 32 would be 288. So the lowest common multiple between 72 and 96 is 288. In a way, 288 is divisible to both 96 and 72. Okay, now at the last page, we are having some basically again some practice questions. This now is GCSE level 5. So looking at these questions, I think you need to give yourself for all of these questions something around 5 minutes. So 5 HCF and LCM of 36 and 64. Solve a fraction 5/15 minus 4/9, and solve an algebraic equation x minus 1/3 plus x equals 5. And then we have simplify 42/72 and 16x3/36x. So you can pause the video now and give yourself 5 minutes. Okay, if you have tried these questions, I am going to quickly go through the answers. 36 to find the prime factors divided by 2 is 18, divided by 2 is 9, divided by 3, because I can't divide by 2, that would be 3 and 3. So 36 is 2 times 2 times 3 times 3. And when we look at 64, we have, again, divided by 2 is 32, divided by 2 is 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. So 64 is 2 times 2 times 2 times 2 times 2 times 2, which is basically 2 to the power of 6. Now, if I put the shared area in here between 36 and 64, I'm going to put it at the top in here. So we have these in here. The shared part, we have 2 2's, so 2 and 2. So for 36, apart from that 2 2, we have another 2 3's. For 64, apart from those 2, we have 4 other 2's, so another 2 and 2 and 2. So highest common factor is the shared area. So the highest common factor in here would be this shared area. So this highest common factor would be 2 times 2, which is equal to 4. But lowest common multiple is the whole thing, just once. So that would be 3 times 3 times 2 times 2 times 2 times 2 times 2 times 2, which if we time all of this together, which is would be basically 64 times 9. Yes, 64 times 9, 558. 576. Okay, so timing all of them together, we will get 576. I just clear this just to make this exactly clear, 70. So now, so that's the answer for that. Solve this fraction. We are looking at basically a lowest common multiple between 12 and 9. So if we do this lowest common multiple between 12 and 9, we will have we will know that that is 36. 36 divided by 12 is 3. 3 times 5 is 15. 36 divided by 4 is 9. 9 times 9 is 36 divided by 4 is divided by 9 is 4. 4 times 4 is 16. So minus 16. So this would be minus 1/36. For solving the second algebraic equation, if you look at here, x is x and 5, we have just one fraction. So x and basically is x over 1 in a way. What is the lowest common multiple between 3 and 1, which is 3? That is the time when we have lowest common multiple is equal to 3. If you time everything to 3 in here, or if I just basically say a common denominator in here, just to keep it a bit simpler. So I'm just going to common denominator. 3 divided by 3 is 1, so that will be x minus 1, plus 3 divided by 1 is 3, 3 times x, equals, now the other side is 5. Now I simplify the top one, would be 4x minus 1, so this would be 4x minus 1. Now time both sides to 3, so that would be 4x minus 1 equals 15. So we can say that 4x equals 16, 1 plus 1 both sides, and then x equals 16 divided by 4, which is 4. And when we look at the simplifications, what is the highest common factor between 42 and 72? I think that would be 6. If we do this again, if you calculate this, 42 divided by 6 would be 7. 72 divided by 6 would be 12. So that would be the simplest form of that fraction. Again, 16 over 36. What is the highest common factor between 16 and 36? And that could be 4. And if we do the 4, that would be dividing by 4. 16 divided by 4 is 4. 36 divided by 4 is 9. And then on x3 over x, we will have x squared. So, which basically this is like saying 4 over 9 of x squared. Okay, hope this video was useful, and we will follow up with more algebraic part and indices. Some of the examples in here are a bit out of this topic, but especially on algebraic equations, but I put it in here because to show the connection between the things that you learn in numbers and the sort of concept that you apply to algebra. This is most of them, they are the same basically concepts. Do visit our website on mathraven.com for more videos and exam papers. For update and support, please subscribe to the channel